Streamlined and turbulent flow, critical velocity. So the streamlined flow is when a liquid flows such that each particle of the liquid passing through a given point moves along the same path and has the same velocity as its predecessor. The flow is called streamlined flow or steady flow. Very simple. The streamlined flow means which has a same velocity. The different layers of liquid has same velocity means in that flow of liquid is called streamlined flow. The turbulent flow means when a liquid velocity exceeds a certain limiting value, that is called critical velocity. If the velocity of the liquid is greater than that critical velocity, the liquid flow becomes zigzag. The path and velocity of the liquid particle is continuously changes. So this type of flow is called turbulent flow. So that means the velocity is not constant. Velocity is not constant. It is the same velocity, different layers. It is a variable velocity. The velocity of the different liquid layers is not same. Velocity is not constant. So the different layers of the liquid has the same velocity means that flow is called a streamlined flow. If the different layers of the liquid flow is not with the same velocity means constant velocity means that is turbulent flow. So when the liquid is flowing with a very small velocity, very low velocity, that flow is called as a streamlined flow. If the velocity of the liquid is increases to the certain value, that velocity is called as a critical velocity. Above the critical velocity, the flow of the liquid is called turbulent velocity. Now we are going to derive an expression for critical velocity. The critical velocity of the liquid is directly proportional to coefficient of the viscosity, then the density of the liquid and the diameter of the tube flow. So coefficient of viscosity of the liquid, density of the liquid, diameter of the tube in which the liquid flow. So we can proportionality is removed with the constant k. So velocity means a dimensional formula. So here also we are going to find the derivation based on dimensional analysis. So L t power minus 1 is a dimensional formula for velocity. For coefficient of viscosity m L power minus 1 t power minus 1, that A will become the as power the power. Then density is mass by volume. Volume is L power minus 3. That is it comes to the numerator. Then the diameter is a length. So L alone. So this is the equation. By equating the powers of the m, L and t separately, we get m power 0, L power 1, t power minus 1. Here m power a, so m power a over, here m power b over. Then L power minus a over, b here it is a minus 3b over, then c is a plus c. For t there is only one term minus a. So we have to compare the powers of mlt. So a plus b is equal to 0, then this term is equal to 1, this minus a is equal to minus 1. Then easily we find that a is equal to 1. So by equating all those things, a is equal to 1, substitute this a is equal to 1 here, 1 plus b is equal to 0, b is equal to minus 1. So a and b we are calculated. By substituting a and b values in minus a, minus 3b plus c is equal to 1 means we get minus 1, minus 3, b value is minus 1, which is c plus c is equal to 1. So this is minus into minus plus, then this value is a plus 2, again plus 2 comes to right side means minus 2, we get c is minus 1. So a is equal to plus 1, b is equal to minus 1 and c is equal to minus 1. Substitute these a, b, c. A is 1 and b and c here. So Vc critical velocity which is equal to k into eta power a. What is a eta power a? A is a 1. So eta power 1. Then rho power b. What is a b? Minus 1. So rho power density of the liquid power minus 1. Then diameter of the tube d is equal to minus 1. So these two terms will become denominator. So critical velocity is equal to k into eta, coefficient of viscosity of the liquid, divided by the density of the liquid into diameter of the tube. So this is a critical velocity formula. By using this formula we can find the value of critical velocity for any liquid which flow on the tube whose diameter is d and the density of the liquid is rho and the coefficient of liquid is eta. So we can able to calculate the critical velocity if you know this k value. So this k is a Reynolds number. This k is called as a Reynolds number. Now we are going to see detail about what is the influence, what is the importance of Reynolds number. So the Reynolds number determines if the Reynolds number value has a certain value, that will be a streamlined flow. Above that value is a turbulent flow. That things we are going to see detail now. So are you able to understand this derivation? Streamlined flow means all the liquid layers has the same velocity. Turbulent flow means the liquid layer has a different velocity. So the velocity of the liquid flow is above the certain velocity is called as a critical velocity. That velocity is above means this flow will become a turbulent flow. We have derived the expression for critical velocity. Now the next thing we are going to study about the importance of Reynolds number. Reynolds number. So already we know that the critical velocity formula is k into eta rho by rho into d divided by, that is a k rho and k eta by rho d. Rho is the density of the liquid and d is the diameter of the tube and eta is the coefficient of viscosity of the liquid and k is a constant. So you keep this k as it is, bring remaining terms here and eta to the denominator. We get the k is equal to rho vd by eta. Rho is the density of the liquid, v is the velocity of the, that is a critical velocity, and d is the diameter of the tube and eta is the coefficient of viscosity. So by substituting the values, these values for particular liquid flow, if you get the Re value, that is the Reynolds number value is 0 to 2000 means that type of flow is a streamlined flow. If this number value for any given flow, if you substitute these values, if the number value is greater than 3000, that is a turbulent flow. Then the flow is between 2000 to 3000 means the flow is unstable. This is not a stable flow of liquid. This is an unstable flow. Either time it can change us to streamline to turbulent flow or turbulent flow to streamline, vice versa. So these are all the importance of Reynolds number. So we can say that Reynolds number is a dimensionless parameter whose value decides the nature of the flow of the liquid through the pipe. So again I will say that the Reynolds number is defined as it is a dimensionless parameter whose value decides the nature of flow of the liquid through the pipe. It is given by the equation rho vd by eta. So understand this concept. So it is very important to determine whether the given flow is a streamlined flow or turbulent flow.